Okay, last video. I know these are long, but there's a lot of stuff. This will be an all-hour lesson if we were doing this in class. Back to this slide here. It's forced a habit for me to talk about the period as 2 pi divided by b. Um, you can also think of it as 360 divided by the value of b. Remember, 2 pi and 360 are the same thing. So we're going to be dealing more with degrees more often than with radians. Like I said, it's just forced a habit to talk about 2 pi over b. Um, these are for the sine and cosine. Remember, what I said in that last video is that if you're dealing with a tangent function, okay, for the tangent, the period is going to be pi over b or 180 over b, whether you're dealing with radians or degrees, okay? The 2 pi or the 360 over b, that's for sine and cosine only. 180 over b is for the tangent function. So what we're looking at is these generic equations. We know what a, b, c, and d do to the equation. And so now it's just a matter of identifying them from our equation to the generic. So in the homeworks, make sure you're paying attention and reading the directions carefully, because it's not going to ask for all of them all at once. It just asks for a couple of those transformations. So first one, amplitude. Okay, that was our a value. We just write amplitude equals 1/2. Okay, it's the number you're multiplying the trig function by. Number 2, amplitude equals 3.5. The amplitude, it is defined as a distance, so it's always going to be a positive number. Okay, so that negative, that's doing a reflection. The negative really has nothing to do with the amplitude. It just has to do with it's reflecting it over the x-axis. All right, here, the amplitude. There technically is a -1, but the amplitude is just 1, like it normally is for that problem. All right, here, the amplitude, 1/4. This is a tangent function, no amplitude for number 5. 2/5 for number 6. Okay, so that's the amplitude part of this. The other thing it asks for is the period of each function. Okay, generically, again, 360 divided by b for the sine and cosine tangent 180 over b. So back to question number 2. Our b value is what you're multiplying theta by. So we're going to have, it's a sine function, so we're going to go 360 divided by 1/2. That's 720 degrees. Dividing by half, same thing as multiplying by the reciprocal. All right, for number 2, the period is, it's a cosine function, so 360 divided by 1/4, 4 times 360, 1200, 1440. Double check that number, whatever 360 times 4 is. All right, we're not multiplying theta by anything here. Well, technically it's 1, so the period, it's a sine function. The normal sine function has a period of 2 pi or, again, 360. I'm used to using radians, so 360 degrees. Okay, you get the idea. For the tangent function, our b value is 2. So 180 divided by 2, this is a 90-degree period. All right? For the next set of questions, it says identify the phase shift. Okay, that was your left to right shifts. That's the theta minus c. So we are subtracting 180. So this is 180 degrees. Because we are subtracting a positive 180, this is a shift to the right. Okay, so phase shift, capital P, capital S. For this one, this is technically theta minus a -10. So our phase shift is 10 degrees left. Theta minus 60. I didn't need to rewrite it, but phase shift is 60 degrees to the right because we are subtracting a positive 60. All right, that's the phase shifts. For the vertical translations, that was your d value, what you're adding after the trig term. Technically, there's a +0. So as far as a vertical shift, we'll do a VS. 0. We're not adding anything. Here, we are adding a negative 2. So this is a vertical shift down 2. All right, you got to be careful with this one. Here is your trig term. We're adding a 3 and a 2. For some reason, they separate those terms, but that's a vertical shift up 5. We've added 3 and we've added 2. Now, this negative goes with this trig term here. So we got a positive 4 and a plus half. So as far as a vertical shift is concerned, that is up 4.5. You get the idea. Okay? So, pay attention. This is what you're looking for. These values, A, B, C, and D, this is what they do to those trig functions as far as a graph is concerned. Now, to graph it, what we're going to do, I'm going to start by graphing the basic one. It says then graph at least one period of the function along with its parent function. So the parent function is just cosine of theta, or cosine of x. Cosine starts at 1 at an angle of 0. It goes down to 0 at pi over 2, down to negative 1. This is supposed to be a nice smooth curve. Back up to a positive 1 here at 2 pi. This point at its minimum here is at pi. Okay, it's supposed to be a nice smooth curve, but it's kind of tough when it's kind of stretched out like that. So now, what we have in our function, because of this 2, that has an amplitude of 2. Because of this pi over 2, we are subtracting from theta. That is a phase shift of pi over 2 to the right. And because of this plus 1, that is a vertical shift up 1. Okay? There is no period change. All right? There is no value of b that we're multiplying the theta by. So, the amplitude is 2. So instead of starting at 1, we're going to start at 2. But now, we've also got this shift up. So we're going to go start at a positive value of 3, sort of. We're also shifting this over to the right, pi over 2. So where this function starts is here, at an angle of pi over 2 at a y value of 3. Okay, we started at the origin, angle of 0. The cosine function starts at a y value of 1 at that angle. Because of the amplitude, we're going to bump that up to start at 2. But now because of that vertical shift up, we're going to go up 1 more. And then that phase shift, it shifted that over to the right by pi over 2 of an angle. Okay, we did not change the period. So what we're doing is basically going to slide this graph to start there. Let me reconnect them down to here. So it's going to go down 1, or go, sorry, it's going to go down 2. Get rid of that. We're going to go down 2, back to 0, up 2. Okay, this is not a perfect graph by any stretch of the means, but it goes up 2, down 2, and back. Okay, your graphs are not going to be perfect. Don't get me wrong, mine's not perfect, but this is the thought process that goes into sketching these graphs. All right, that is it for this. This is a long lesson. Like I said, if we were doing this in class, we'd be going right up to the bell. So the assignment will be up on the board. Email me to ask questions. I'll be here in the mornings. I got to leave around a little after 7, 7:10, somewhere in there. So send me some emails and I'll be more than happy to answer questions. Bye.